All right, welcome everybody. Uh, Today's webinar, The Future of the Smart Factories. I'm Janne Honkonen, the founder and CEO of Advian, a company specialized in industrial AI software and solutions. Today, I'll share you with our approach for smart factories, interesting reference case from the steel industry, and our solutions, how to enable smart factories, and also some key takeaways while you are planning your factories. Uh, just a second. So, our approach for the smart factories, we approach the implementation with a very business-driven model. So every single solution you implement on your factories should be based on the value it delivers for your operations. I always remind my audience about the case that I was discussing with the customer. They seemed to be happy with the solution. They had 3,000 sensors in their factory, and each sensor was sending data to the cloud once per second. Once we asked what the customer is doing with the data, the answer was long silence. So do not start your cases with the IT-driven approach. Think about the business. How are you going to utilize the data in the long term? The five approaches, the five phases we have in our approach are: you have to choose the right battles. There must be the business case. Do not start with the fancy technology or easiest case. Make sure the return of investment is good enough. Comprehensive data capturing. You can gather data from operation from different sensors, IoT cameras, from the equipment on the production, or from external systems. That's a critical phase. Data harmonization. Smart factory, it requires comprehensive harmonized data. Individual machines can be optimized with the smaller data sets, but if you want to kind of think about the whole factory, the data must be harmonized across all the kind of equipment where you're gathering the data. Real-time AI capability to give you insights, what's going on in the production, and also giving you predictions what should be done to make the production more efficient. And also a real-time automatic production control, how to kind of remove the human factor from the process. These are the five phases in our approach. What we have seen in our customers, this kind of implementation usually takes three phases. First, companies want to gather and visualize the data. Even this kind of transparency helps a lot to understand what's really going on in the operations. The next phase, what we have seen, is that start using AI machine learning to give predictions, what is supposed to be done, what will happen in the future, but still let people, operator, key user, to make the final decision. And the last stage is the fully automated solution driven by edge AI or AI in general. And in that case, we have taken the human factor out of the process. In this context, edge computing and edge AI plays a crucial role. So what is this edge AI we are talking about? It means, in general, we are bringing the computing power together with artificial intelligence from the cloud near to the service or the machine where the data is being collected. There's three main drivers behind the edge computing. Of course, the one is the low latency. So if you have to react, say, in milliseconds, you don't have time to send the data to the cloud and back. You have to kind of calculate and process the data real time alongside of the production line. Another reason is scalability. So you can utilize multiple data streams, multiple sensors in one go to get even more powerful analytics. And the third factor is the security. Once you are processing the data at the edge, you are not sharing and exposing the data with any kind of external parties when you are sharing it to the cloud. The price of the computer power has reached a level where most of the factory floor tasks can be automated, even powered with the edge AI. And that actually opens up new applications and new opportunities even for smaller factories. The question why edge AI matters then. Data and AI, they will be a key role once we are moving from individual robots, for example, taking care of repetitive tasks, to more intelligent autonomous systems. Automation, together with AI, it enables to mimic the human behavior, which means that, okay, we can replace human from the process, and same time we can even improve, for example, the quality. Machine still usually does a better work than an individual who has kind of a lot of dependencies, who is doing the manual work, and Monday, Friday usually is a different from individual people. Machine is stable, makes a better quality than a human. And like Gardner states here, the innovation, operational excellence, those are the main drivers for edge AI. And once we are combining AI with the production data, we also make the much talk about IT/OT convergence to become more reality. But that's the background. Let's move a use case I promised to share with you. We have been working some time with the market leader in stainless steel products. Their aim, while they started implementing their smart factory, was to improve their overall efficiency not less than 50%. Of course, it's not all coming from the kind of edge AI side of things, but our cooperation started with the quality assurance side. That was part of the objective. But here we actually implemented a 3D machine vision, machine learning, and robotics-based solution alongside of the production line, with the aim to identify several kind of defects in the products. It can be dimension issues in the pipe thickness, incorrect cuts. Also, we try to identify defects in the surface. They have also stamps in each product. We have to ensure that those are correct ones. What makes this bit interesting case, they have quite strict requirements for the quality kind of deviation. So 0.5 millimeter was the level of accuracy which was supposed to be kind of identified in all cases when we talk about the defects in smaller or wider pipes. But this kind of product quality at the end of the production line was only one part of the solution. We also gathered data, operative data from the production machines, to understand which were the process parameters used while these kind of quality defects took place. Also, we used the material data that customer has gathered to understand, is there some impact when we're comparing different material sets which are coming to the factory. Finally, we implemented different kind of machine learning algorithms, and with those we were able to identify the root causes behind the product quality issues, whether those were behind of the reason for incorrect process parameters, or if there was a reason that certain set of raw material was defective. And at the end, the final step was the real-time adjustment of the process automation. So also here we removed the human out of the process. No need for human to make the inspection, no need human to kind of adjust the process automation. The outcome, autonomous system, which improved the efficiency of that production line, we started more than 10%. Of course, in the long run, in optimal case, the whole factory should be driven by data. In that case, different production phases and automation systems are linked to each other with the data. Also, data is used to optimize the whole production process instead of individual automation systems. Last week in the MPD, there was a lot of vendors talking about how they automate their own machine system, but the problem still remains how to make these individual systems work together. And there, the data harmonization will once again come into picture. Also, the production line data is important for this customer to use to maximize the uptime. They don't have much issues with that, but they want to kind of aiming for, say, not 100% quality, but want to ensure that they don't have any unnecessary downtime in their machines. So overall, we are talking about system thinking. Factory operation, supply chain must be all optimized to achieve the maximum performance. And for this customer, it means this 50% efficiency improvement they're looking for. Our solutions. So our modular Edge AI platform, it enables multiple different use cases. For example, when we talk about product or material quality, to this date, most of the manufacturer's quality control is still manual. It's time-consuming, costly, unreliable. It's based on subjective interpretation of the individual. Also, some customers, they have implemented automated solution, but in many cases, those are point solutions doing one individual thing. But in our solution for inline inspection, whether you are checking the quality of the ready product or incoming component, incoming raw material, you can do 3D dimensional inspection. You can check the surface quality if there's scratches, paint leaks, etc. You can do correct assembly analysis, making sure you have the right screws and bolts and spin wheels in place. Or you can do different kind of material composition analysis. All these with one solution, with one go. No need to separate solution for 3D inspection and 2D inspection. Production optimization. We also talk here about a lot about transparency. Some companies are using industrial digital twins, mostly used for simulation purposes. But if you include this kind of digital twin, also your kind of components on products, the data directly from your production line, it opens tons of new opportunities. Meaning you can detect, identify, improve the traceability of your production materials. You can reveal bottlenecks in the production process. Nowadays, what we have discussed with customers, we have seen many cases that customers really don't know what's going on in the production process. In some cases, you see from the manufacturing execution system, okay, now the production set started, and then next thing you know, that it came out from the production line. But then you are wondering, wow, our kind of capacity is only 70 or 60% of the maximum, but you have no idea what's going on there. The question is how you implement the transparency in your solution, understanding where the components go, where are the bottlenecks, and with that way you can optimize your production next step further. Preventive maintenance, a lot of increasing trend. The increasing trend is move from calendar-based maintenance to more kind of condition-based maintenance, meaning that you make sure that you do just-in-time maintenance activities, your equipments, not too early, not too late. Idea is to kind of you make sure that equipment is fixed and replaced with the minimal loss of productivity. And of course, you can do predictive maintenance also in real time while you are utilizing Edge AI. You don't have to kind of send the data to the cloud and wait for the next morning to see what it's supposed to be. Especially in the cases where you have the risk that misuse of the device can make the device broken. So if you can identify in real time certain kind of sensor combination will break the machine, then you can react in time as well. Then at the end, like I have stated, the data, when data is gathered and used effectively throughout the factory, we are also able to re-evaluate or renew the existing processes, not only automate the same old tasks that we have done before. Another thing, do not underestimate the practical experience of your employees. Guys who has been on the production line 10, 20, even 30 years, they have such a kind of tacit hidden knowledge that you are not able to identify. So make sure that you involve your key persons heavily while you are automating and digitalizing your process or smart factory. There will always be surprises. So data together with people, processes and technology. That's our recipe for future smart factories. Thank you.